So in section 10.4, we're going to begin with the algebra of matrices. We're going to learn how to add and subtract multiples of matrices and also multiply matrices. That's the ultimate goal in this section. So we've already typed in these matrices into our calculator. You should double check that you have those entered correctly by typing out the matrices, making sure that they match what you expect. And they do. Great. So let's get started. We can start with problem number 24A, which asks us to subtract matrix C minus matrix B. Now notice that matrix C and B have dimensions that line up. So I can do the subtraction. When you do the subtraction, you're going to subtract elements that are in corresponding spots. So in the upper left-hand corner, I'll have a 2 minus a 3. So when I do C minus B in my matrix here, I should end up with a negative 1 in the upper left-hand corner. Negative 5 halves minus 1 half is negative 6 halves, which is negative 2. So all you have to do is type those in, hit second, and then matrix. Let's do C minus second matrix B. And there you go. You know what? I did a little arithmetic mistake, right? Negative 6 divided by 2 should be negative 3. In any case, it matches what we expected. So, okay, that's good. You can do other things. And let me just kind of show you part B a little bit. You can do 2 times a matrix. So 2 times B would look like this. And what are they doing to do 2 times B? What's happening when I do 2 times B? Yeah, it multiplies each number by 2. And in fact, we can do 2 times C minus 6 times B. So that's going to be 4 minus 18 would be negative 14. In fact, let's just let our calculator do all the work here, right? Type that in. 2C minus 6B. And we get the negative 14 in the upper left-hand corner like we expected. Nice. Nothing really too unusual or crazy here. But what about multiplication? What if I try to do C times B or B times C? Let's try that. Matrix B times matrix C. It doesn't like it, does it? Dimensions mismatch. This is a big red flag for you. It's like, okay, something's wrong. Now, multiplication of matrices is not just multiply this times this, this times this. That's not how multiplication of matrices works. So I've given you a handout. You should take out that handout. And let's start by understanding a requirement that's implied by what I have up here. That is, if you're multiplying 2 matrices, say matrix A and matrix B, their dimensions have to line up properly. So let's say A is an N by M matrix and B is an M by P matrix. So that's its dimensions. By the way, remind ourselves, which dimensions comes first, rows or columns? Rows. It's always row then column. RC cola, right? These have to match. If they match, if the number of columns in A matches the number of rows in B, then you can do the multiplication. And if they do match, then this is going to be the size of your product. Size of the product. That's how big the matrix is going to be when you multiply those things together. So just a minute ago on your calculator, I had you multiply together a couple matrices, and it wouldn't do it. Let's understand why. This is kind of a similar example. What are the dimensions of this matrix? 2 by 3, and this is also a 2 by 3. But if you notice, those two indices don't match. They don't equal each other, so you can't do the multiplication. That's it. You just can't. So, wow. This matrix multiplication stuff is really weird. In fact, let's take a look at this one down here. B times C. B times C. Well, that's these two matrices. Can I do it? B times C, the dimensions of B, 2 by 3, times a 3 by 2. So those match, that checks. And the size of your product, you're going to end up with a 2 by 2 matrix. Now, before I show you how to multiply these things, let me just show you that multiplying matrices is really different than stuff that you've dealt with before. So what you're used to is that things are commutative. And by that I mean 7 times 8 equals 8 times 7, right? The numbers commute. They can change order and you still get 56 either way, right? Let's take a look at what would happen if I multiplied B times C. Well, excuse me, how about the other way around? C times B. There you go. So C is a 3 by 2 matrix, and B is a 2 by 3 matrix. Can I multiply them? Yeah, that checks. What's the size of the product going to be? 3 by 3. Well, wait a minute. Wow, this is really different. On the one hand, you get a 2 by 2. On the other hand, you get a 3 by 3. So these things are not equal. The order in which you multiply matrices makes a difference. So how do you multiply matrices? That becomes a little bit of a challenge. The good news is that you can double check yourself on your calculator. The bad news is that you're still going to want to see some of the work. I'm not going to give you one that's really hard. All right? Trust me. So let's first start by multiplying B times C. And I'm going to call matrix B times C, let's call that matrix Q, just to give it a name, just so I can refer to it. So that's going to be matrix Q. And matrix Q is going to be a 2 by 2 matrix, right? It's going to be the outside dimensions. So that means that Q is going to be made up with little elements. I'll call this Q11, Q12, Q21, and Q22. And the reason I want to focus in on those little elements is because this is going to help us understand how to multiply these matrices. Now, the way I generated these numbers is this. The first one is the row, second one's the column. So this is first row, first column. First row, second column. What? Second row, first column, second row, second column. When you multiply matrices, you're going to have to borrow a row from the first matrix times a column from the second matrix. So let's step back and take a look at B times C and see what that's going to mean for us. So B times C, well, this is your first row of B times the first column of C. Let's see if we can't multiply those together. Now, multiply, again, is kind of strange because it's not just, a number times another number. It looks like this. Here's your row for B. Here's your column for C. It's going to be negative 3 times 9 plus 12 times 4 plus 8 times 6. And all that's written right here, that's our Q11. So it's exactly what we just did. Negative 3 times 9 plus 12 times 4 plus 8 times 6. And let's just leave that there for a moment. We'll do the arithmetic later. Let's move over to this one. What's this one going to be? Q what? 1, 2. First row, second column. First row, second column. So you go to the first row of B times the second column of C. So it's this row and this column. Negative 3 times 1 plus 12 times 3/4 plus 8 times negative 5, and that gives you Q12. Down over here, Q21. So to get Q21, Michael, what do I multiply together to get Q21? So, let's see, from C, actually we'll start with B, right? B row 2 and C column 1. So it's going to be row 2 times column 1. So 4 times 1 plus 0 times 3/4 plus 1/9 times negative 5. That's exactly what we have here. And the last one, how would I subscript this? What's this one called? Q22. Second row and second column. So second row from B times second column from C. 4 times 1, 0 times 3/4. You know, did I screw up when I did screw up. Yeah, this one should have been Q21. Should have been 4 times 9, 0 times 4, negative, or 1/9 times 6. So that should have been Q21. And I accidentally did Q22 just a minute ago. But here it is again. 4 times 1 plus 0 times 3/4 plus 1/9 times negative 5. So that's Q22. When you multiply these things up and add them all up, you get the product, which is your product BC. And you can write BC. They also wrote it as Q. That's fine. It's still the same. Well, you know, I guess it kind of depends on you, but in this case, the 2 by 3 on the left works out nicer because you end up with a 2 by 2 matrix. Here, you're going to end up with a 3 by 3 matrix, so it feels like there's more work. I always work these things so that you don't have a really big matrix to deal with. I am going to ask you to do one by hand, but you can check yourself on your calculator, and it's going to be a small one. I can give you nice integer numbers. I'm not going to give you decimals and fractions. I just want you to show me that you paid attention a little bit during lecture. So let's try it the other way. If I did C times B, now I know that I'm going to get a 3 by 3 matrix. So I'll call this matrix my product matrix, P. And for instance, this would be P11. Let's focus in on this one over here. What row and columns are going to be multiplied together to give me this one? Well, what? That's going to be P23. So somebody said it. Second column, third row. So it's always row then column. So remember, our corporate sponsor, right? Back here, RC Koloff, row then column. Yay. So coming back here, second row, third column. Let's see. Second row, that'd be of matrix C. So that's this row times this column. So 4 times 8 plus 3/4 times 1/9. There you go. Try and pick another one at random and see if you can't match, what to multiply by with what I have down there. So pick another one, sort of at random. You know, maybe something on the third row here, other than 3 and 3. See if you can't multiply those two together. Okay, so let's take a look at P31. Since you're multiplying C times B in this case, I want the third row of C times the first column of B. So third row from C times the first column of B. I should end up with 6 times -3 plus -5 times 4. If you do the arithmetic out, you'll end up with -38, and so on. Application. Sure. Well, you mean as far as multiplying matrices? Sure. That's a great question. Let me tackle that one directly. Well, programming, I mean, one thing to keep in mind is that when you store a picture file, a lot of them are stored as JPEG, which is something different than I could get into. But some of it is stored as just numbers. You have numbers that represent colors. And then when you want to modify your picture, maybe you want to make it a little bit darker or increase the contrast. You're doing operations on matrices is really essentially what you're doing. So that's a good application. But as far as exactly what you're saying, let's take a look at this one, matrix multiplication. So we've got this fast food joint, and these are the sales in hot dogs, hamburgers, and milkshakes. And this is how much each of these cost. It asks us to multiply B times A. So, okay, let's maybe do this one. Let's, first of all, write down our matrices, B and A, and then we'll multiply them. So, problem number 56. Matrix A is going to be 4,000, 1,000, and 3,500, underneath which we have 400, 300, and 200, and then 700, 500, and 9,000. So that's matrix A. Matrix B is how much each of these items cost, or sells for maybe. And we're going back to, I'm guessing, the early 70s maybe, because your hamburgers cost 90 cents, your hot dogs cost 80 cents. Certainly they're not going to the Imagine Theater. And your milkshakes cost $1.10, and that's matrix B. Now they asked us to form B times A. They want us to form that product. And these are your different stores. So you have a store at Santa Monica, Long Beach, and Anaheim. What state are we talking about? California, yeah. And these are your hamburgers, these are your hot dogs, and and this is your milkshake. So these are the sales for various stores, and this is the price of hamburgers, hot dogs, and milkshakes. Let's take a look at the dimensions involved. What are the dimensions of matrix B? Good. It's going to be a 1 by 3. What are the dimensions of matrix A? 3 by 3. And when I multiply these together, what I'll end up with is what? A 1 by 3. Notice that this problem would not work in the other direction. If you accidentally said, oh, I want A times B would be a 3 by 3 by a 1 by 3, and you can't do it. These inner indices don't match. Okay, so let's do this. What's the size of the matrix that I'm going to get by multiplying B times A? It's going to be a 1 by 3. So let me write a 1 by 3 matrix. 1 by 3 matrix. So what do you want to call this matrix? You want to call it Q? You want to call it P? C? C for cost, or C for cash? All right, so we'll call this C11. What would this next element be? C12 and C13. Okay. Let's figure out each of these terms here. So for C11, I'm going to multiply the first row of B times the first column of A. So what would that look like? It's going to be 0.9 times 4,000. 0.9 times 4,000. Keep going. Plus 0.8 times 400. Plus 1.1 times 700. So that's C11. And I'm going to kind of stagger these across the bottom here. Let's do C12. So it's going to be the same thing. I'm going to have this row times this column. So it's going to be 0.9 times 1,000 plus 0.8 times what? Times 300. Good. Plus 1.1 times 500. On the last one, I'm staggering these. I'll write it eventually like this. Let's see. Why don't you see if you can't beat me to the last one? Try and multiply and get C13. So row 1 times column 3. Wow. A lot of milkshakes in the Anaheim store. All right, so that's our product. I'll tell you what, I'm going to do it this way. I'm going to store these, I'm going to edit these matrices. I'm going to put them into my calculator. So let's edit matrix B. That's going to be a 1 by 3. And that was 90 cents, 80 cents, and $1.10. And matrix A was a 3 by 3 with entries of 4,000, 1,000, 3,500, 400, 300, 200, 700, 500, and 9,000. So I wanted to do B times A. So let's do that. Second matrix, times A. Oops. What did I do wrong? I shouldn't be getting negative numbers here. A. B times A. That doesn't look right at all. Are you guys getting something different? B. Oh, I typed in negative 0.9 by accident. No wonder why. Let's see, I got to go edit that. 0.9. There we go. B times A. Whoops. How about B times A? There we go. This is what you guys getting. 4690, 1690, and 32 or 13,210. What do these numbers mean? What do they represent? I mean, you asked for an application. This is an application. What do these represent? Oh, okay. It was, so the original problem was this one. It talked about the sales of various items in these three different stores. And we multiplied the number of units sold by the price. Yeah, so it's their total sales for these items in each of the three stores. So in the first one, that's your total revenue from sales in your Santa Monica store, and then your Long Beach store, and then your Anaheim store. Anaheim killed it, yeah. But it's giving you the total for each store. So that's an application of matrix multiplication. All right? Good question. All right, let me get you out of here. Get you some homework. Let's see. Mostly what I want you to work on right now is the matrix multiplication and some of the stuff that we did earlier, like 2b minus 6c, that kind of thing. So why don't you start by working with problems 23 through 33. All right, we'll do some more next time. See ya.